do hurricanes get names? Every year around the end of the summer, hurricane season starts in the US when huge tropical storms start to pop up. These massive storms are rated on a scale from 1 to 5, 1 being the weakest type of hurricane and 5 being the most severe and dangerous. But even a Category 1 hurricane, the smallest kind, has winds between 74 and 95 miles per hour. Any storm that's Category 3, 4, or 5 is considered a major hurricane that's likely to cause damage to buildings and the environment. Category 5 hurricanes happen whenever the wind is blowing at more than 157 miles per hour. That is very dangerously windy. Buildings, roofs, trees, and power poles are all at risk of being severely damaged when the wind is whipping around that fast. Part of what makes a hurricane so dangerous is that, unlike other natural disasters like an earthquake or a tornado, a hurricane can last for a long time, sometimes longer than a week. That's because hurricanes are huge weather systems that move pretty slowly, only about 10 to 20 miles per hour. Creeping along slowly means the rain, waves, and wind all have plenty of time to damage whatever it's passing through. Hurricanes only develop over warm water that's 80 degrees Fahrenheit or above. When the warm, wet air over the tropical water rises, it's replaced by cooler air from above. That new cooler air will then start to warm up and rise, being replaced by new cool air again. When this cycle is repeated over and over again, huge storm clouds eventually start to form. These clouds start to spin with the rotation of the planet and get bigger while wind speeds increase, only causing the cycle to happen faster and eventually forming a fully fledged hurricane. Nowadays, hurricanes are each given their own individual name for one simple reason. It makes it much easier for meteorologists to track and identify each hurricane forming, since there's often multiple hurricanes forming at any one time, sometimes in the same area of the ocean. Naming them simply makes things less confusing. Since 1979, the names have been picked by the World Meteorological Organization, who use 6 lists of male and female names to choose from. The lists have a name for each letter of the alphabet except for Q, U, and Z. So, next time the power goes out and you're hunkered down safely during a storm, well, at least you know you can bust out this semi-useless fact to pass the time when you're bored. What is air actually made out of? Most people assume that the air around us is mostly made of oxygen. After all, we know we need to breathe in oxygen in order to survive. But the truth is, oxygen only makes up a fraction of the air we're sucking in with every breath. The exact oxygen level in the air can change depending on where you are, but generally it's only about 21% of the air. The closer you get to the ocean, the higher the percentage, and the farther away you get, the lower the oxygen levels. So, for example, if you were standing at the peak of a tall mountain range, you'll have much lower levels of oxygen in the air. How low? Well, at the peak of Mount Everest, the highest mountain on Earth, oxygen levels are only about 1/3 of the average. Why? Well, about 50 to 80% of all the oxygen on Earth comes from our oceans. Most of that oxygen comes from plankton, tiny pieces of plant, algae, or bacteria that can turn sunlight into oxygen. Okay, so now we know that only about 21% of the air we breathe is actually made up of oxygen, and sometimes even less than that. But then, what makes up the other 79% of air we suck up all day? Well, it turns out that about 78% of the air is actually made up of another common gas that, honestly, doesn't do much for our breathing at all: nitrogen. That's right, even though nitrogen makes up more than 3/4 of the air, we simply breathe it in and breathe it right back out again unchanged. So, between nitrogen making up about 78% of the air and oxygen making up another 21%, that makes up 99% of the air we breathe. So, what makes up that final 1%? all kinds of things. Trace amounts of other gases like argon, carbon dioxide, nitrous oxide, neon, helium, hydrogen, or methane, just to name a few. There's also differing amounts of water vapor in the air at any time, depending on how humid it is outside. There's more water vapor in the air on hot summer days and less in the cold of winter. And that's not all you can find in the final 1% of the air. Dust, pollen, microbes, spores, and even things like scent particles also help make up that last little sliver. So even though we might not be able to see the air around us, now we know almost 80% of it is, honestly, kinda useless. The more you know. What will the Earth be like 1,000 years from now? Technology is continuing to process at such an amazingly fast pace that chances are things could look very different, even in the near future. So 1,000 years from now? Well, if you ask experts, things could get very different. For starters, humans might look a little more sci-fi. Some experts think it might become common for people to implant tech right into their bodies, kind of like a real-life cyborg. Programmed medical bots and nanobots could revolutionize surgery, and synthetic brain implants could maybe even make us capable of downloading skills on the spot, accessing the internet with just our thoughts, and much, much more. And it's not just our physical appearance that might change in the next 1,000 years. Given the rate that the processing power of computers is progressing, there's a chance that we could end up with supercomputers that can perform and think as fast or faster than a human brain. These artificially intelligent computers would be able to speak, listen, and learn faster than the human mind, making them smarter than humans, which could definitely pose its own problems. So yeah, the truth is, it's not all sunshines and rainbows when you try to predict ahead 1,000 years. And it's not just the technology that we might need to worry about. We could be in for some light extinction that far in the future. Now, no need to panic. The Earth isn't in the brink of an instantaneous mass destruction. That would take something highly dramatic, like, I don't know, a massive meteor. But what the Earth does seem primed for is possible mass extinctions of lots of plants and animals we know today as we continue to populate and pollute our planet. Already in the past 100 years, the rate of extinction for species across the planet was 100 times higher than normal due to human impact. That's significant, and if the trend continues for the next several hundred years, well, then we might lose a lot of the plants and animals we take for granted today. Luckily, there is always a chance that we slowly start to change how we interact with the planet and decide to develop brand new tech in time that helps solve some of our issues before it's too late. There's already tons of people around the world working to solve these problems. And in 1,000 years? Well, there's no telling what genius solutions we might find to stave off extinctions and help the planet thrive. Nanotechnology powered by the sun might be able to clean up the land, air, and sea like super advanced Roombas. And in the future, we might continue to develop cleaner sources of energy that require a lot less drilling, spilling, and polluting the skies. Hey, there's always a chance, right? And if not, well, there's already plenty of people who think that 1,000 years from now, humans might not need to live on Earth at all. We could have human colonies on the moon, Mars, or even a yet-to-be-discovered Earth-like planet somewhere else in the galaxy. It sounds far-fetched, but scientists have already found more than 40 billion Earth-like planets in our galaxy alone. So, who knows? Maybe it all won't be science fiction after all. Why are all of the planets round? You probably know that there's 8 planets in our solar system. And you might know that those 8 planets can be pretty different. Some are massive, and others are relatively small. Some are rocky and others are made up of gas. Some spin super fast and others don't do much spinning at all. But no matter the difference, each and every planet we've ever found in our solar system or anywhere else in the galaxy are all round. What's the deal? Why can't planets be any other shape? Well, it has to do with how planets are formed. It all starts when little bits of molten space debris, like liquid hot chunks of rock or gases, bump into each other and start to clump together. Eventually, after collecting enough debris, the big glob becomes heavy enough that it starts to have a good amount of gravity. Gravity is the force that holds stuff together in space, pulling everything towards the center. Now a big, heavy floating lump, it starts to orbit its nearby star, pulling anything in its path into its gravity along the way, making it even bigger and even globier. The big, molten baby planet's gravity pulls equally as hard from all sides, which basically means that everything is about as equally close to the center of the planet as anything else, making it a ball. So that's why all the planets in our solar system are round. But some are rounder than others. For instance, Mercury and Venus are both almost perfectly round, like floating marbles. Saturn is a bit thicker around the middle, making it the least round planet in our solar system. Why that extra thickness? Well, think of a big spinning planet a bit like a carousel. The faster you spin, the harder it is to stay on, and the easier it is to get thrown right off. This is called centrifugal force, and it works the same way for things as colossal as planets too. As the planet slowly cools down and eventually hardens, it keeps its bulging shape. So, sorry to burst your bubble if you were holding out hope that scientists might find a strangely shaped planet somewhere out there in space. But hey, you know what they say, never say never. Why are most plants green? In order to understand why most plants are green, we'll first have to learn how we even see color in the first place. You see, every time you look at something, you're not actually seeing the color of the thing itself. Instead, when light shines on an object, it absorbs some colors from the light and reflects others. The colors we see when looking at stuff is actually just the light that different objects are reflecting back into our eyeballs. Trippy, right? So, the reason grass, leaves, and other plants look green is because the plants are absorbing all the other colors and just reflecting the color green back to our eyes. Okay, so that's how we see colors, but why green? Why do most plants only reflect green back at us while absorbing the rest? Well, that has to do with a very special chemical inside plants called chlorophyll, which is what they use to make their food. The chlorophyll inside the leaves traps light from the sun. The plant then uses that stored up light energy to change water and chemicals in the air into sugars and oxygen. The plant eats the sugars and releases the oxygen, which we breathe. This whole process is called photosynthesis, and it's super important. Why? Because without it, plants couldn't eat and we couldn't breathe. And none of that would be possible without chlorophyll, which just so happens to absorb all the reds, blues, and other colors and reflects green light back into your eyes. That's also why some parts of the plant might look more green than others. There's usually a lot more chlorophyll in the leaves than the stem of a plant, which is why the stems aren't usually quite as dark. And not all parts of a leaf always have the same amount of chlorophyll. Some leaves have light green, white, or yellow stripes, or spots on them. There's also some plants that have yellow, red, purple, or orange leaves year-round and never look green. Don't worry, those plants get to eat too. They still have plenty of green chlorophyll in them, but those kinds of plants also have lots of other chemicals in their leaves that are other colors, enough to blot out the chlorophyll's green hue. So, why are plants green? because chlorophyll is green and plants are full of it. So, whenever you see a nice green plant, you can thank that special green light bouncing chemical, chlorophyll. What's the absolute deepest point in the ocean? Throughout history, if you wanted to measure just how deep a body of water was, you had to tie a weight to a rope and let it drop to the bottom. Then measure how much rope went in the water. Not too hard. But when it comes to the ocean, it would take thousands of feet of rope to measure some of the deeper parts. So, for centuries, no one really knew just how deep our oceans are. That is, until the late 1800s, when a British Navy ship named the HMS Challenger set out on a voyage to learn more about the briny deep. The ship was outfitted with over 900,000 feet of hemp rope, more than enough to reach even the deepest, darkest places. During the 4-year journey, the crew of the Challenger managed to find the bottom of the ocean, the Mariana Trench. This massive crack in the Pacific Ocean stretches for more than 1,500 miles. Even still, the HMS Challenger found what is maybe the single deepest point, now known as the Challenger Deep, on the southern end of the Mariana Trench. Nowadays, experts use high-tech, state-of-the-art sonar technology to precisely map the ocean floor, giving us a much clearer picture of what the trench looks like and exactly how far down the Challenger Deep really goes. 35,856 feet! That's close to 7 miles! That's deep. Really, really deep. How deep exactly? Well, the diving limit for recreational scuba divers is 130 feet. That's about the height of a large building. Pretty deep. Blue whales, the biggest known creatures to ever live on Earth, can dive down to more than 1,500 feet. Double that depth to 3,000 feet, and sunlight can no longer penetrate the water. The wreck of the Titanic sits on the cold ocean floor, about 12,000 feet underwater. And on average, the Earth's oceans are about 14,000 feet deep. To put those depths into perspective, the tallest skyscraper in New York City is a mere 1,776 feet tall. The absolute deepest shipwreck ever uncovered sits at the bottom of the Philippine Sea, 21,180 feet down. The Atlantic Ocean goes even deeper than that, maxing out at 27,500 feet. For comparison, Mount Everest, the highest place on Earth, is 29,032 feet, just a few thousand feet taller than the Atlantic Ocean is deep. Whoa! But even the mighty Everest can't come close to competing with the Pacific Ocean's Mariana Trench. The Challenger Deep, the deepest known point in the entire ocean, is an amazing 35,856 feet below the waves. Because no light can penetrate that deep, and because the pressure of the water above is so insanely immense, only highly specialized submersibles are able to venture down into Challenger Deep and explore. Down there are some of the most fascinating, strange, and in some cases horrifying creatures on the planet. And the more we explore, the more we find. And who knows what they'll find next? What are the Northern Lights? The Northern Lights are a stunning series of bright colors that appear to flutter across the sky near the North Pole. The eerie natural phenomenon can make a normal night look a bit like a science fiction film. Most of the time, the Northern Lights glow green or blue, but they can also glow brown, red, or purple. Experts call this kind of special light an aurora. Way up near the North Pole, we call them the Northern Lights or Aurora Borealis. Down near the South Pole, they're called the Southern Lights or Aurora Australis. Makes sense. But whether you're near the North Pole or the South, the view is all the same. A bright, colorful, all-natural light show unlike anything you'd find at a theme park. Like just about all the natural light you see on Earth, the northern lights come from the sun. You see, from time to time, huge amounts of energy burst out of the sun. These are called solar flares. They're a type of storm on the sun's surface. When a flare happens, massive amounts of electrified gas burst out and flare up, hence the name. This gas is full of tiny atomic particles called electrons. When the gas from a solar flare reaches Earth, some of it ends up in our atmosphere. As those electrons from the sun finally start to interact with different gases in the air, it causes that strange, beautiful light show in the sky. Why the different colors? Well, it depends on which gases the electrons interact with. The most common color you see is lime green, which is caused by oxygen molecules between 60 and 150 miles up. Once you go above 60 miles, the oxygen that mixes with the electrified gas becomes more of a yellow instead. Above 250 miles, it turns a bright red color, but this is more rare. Blue and purple appear less often too. They're caused by particles colliding less than 60 miles up. At those heights, it's nitrogen, not oxygen, that causes the lights to turn purple or blue. Okay, so that's why the northern lights happen, but why do we only see them at the poles? Well, that's because of the electric charge in the gas. You see, as those electrified gas particles enter the atmosphere, Earth's magnetic fields guide the electrical charge towards one of the two poles. All that built-up electric energy is finally let out in the form of flashy colors. It's no wonder that people throughout history tried to find all sorts of mystical ways to explain it. Vikings thought it was caused by the shiny weapons of long-dead warriors. Inuit people believed they were the souls of animals. And the Menominee Indians thought the lights were the torches of giants living in the deep north. And it's no wonder why they were searching for an explanation. The unique beauty of an aurora borealis still attracts people from thousands of miles away. So, mystical or not, they're definitely mesmerizing. Just how hot is the center of the Earth? The center of the Earth is close to 4,000 miles beneath our feet. That's deep, really deep. If you wanted to tunnel your way down to the center of the Earth, you'd have to dig through the planet's 4 layers: the crust, the mantle, the outer core, and the inner core. The outer layer is the crust, made up of solid rocks and minerals. In all our years digging into the ground, humans have never been able to dig past the crust, even with state-of-the-art equipment. It's a bit like the crust of a pie, a thin, hard outside layer that makes it look solid, even if the insides are gooey. Compared to the other layers of the Earth, the crust is actually quite thin. Under land, it ranges from 19 to over 40 miles thick. But beneath the oceans, the crust can be just 3 miles thick. Considering that the center of the Earth is 4,000 miles down, just a few miles of crust isn't much. Even still, humans have never managed to drill any deeper than 7.6 miles down. That deep, temperatures are so high, over 350 degrees Fahrenheit, that the drilling equipment breaks down in the unbearable heat. 350 degrees is hot. So hot that humans couldn't survive it. Yet it's not even close to how scorching hot it gets at the center of the Earth. Below the crust is the largest layer, the mantle. It's also mostly solid rocks and minerals, mixed with soft, semi-solid areas of molten magma. The mantle is over 1,800 miles thick and is mostly made up of elements like iron, magnesium, and silicon. Beneath the mantle is the Earth's core, which is split into 2 sections, the outer core and the inner core. The outer core is big, almost 1,400 miles thick, and it's mostly made of liquid iron and nickel. The inner core is incredibly dense. Just like the outer core, it's mostly made of iron and nickel. But unlike the outer core, experts believe it's hard rather than liquid. Okay, so that's all the different layers of the Earth, but how hot does the core actually get? Really, really hot. The edge of the outer core is about 7,000 degrees Fahrenheit, and the inner core is even hotter, over 10,000 degrees Fahrenheit. That's about as hot as the surface of the sun. So next time the sun is beating down on your back on a scorching hot summer day, just remember, it could definitely be worse.